All right, so guys, listen. All right, so before we went on the break, we talked about, or we started Unit 6. We talked about ionic bonds. And then today we're going to do Unit 7. We're talking about covalent bonds. So Unit 6 and Unit 7 are together. You did have a quiz before you left for Thanksgiving break, and it closed the Sunday before Thanksgiving break at midnight. When I left here Friday, I did not look at Canvas at all until this morning. So I came to work this morning with many, many messages saying that the quiz was not correct or something was wrong with one of the questions. So if you send me a message online saying that the quiz was wrong, thank you, I appreciate it. I did fix it and I did send you a message back. But so everyone knows and everyone is on the same page, I have fixed the quiz. I have reopened the quiz until Wednesday at midnight, and I have allowed 2 attempts, and it will take your highest attempt. So if you still need to take the quiz, it is reopened for you to take it. If you did take it, but it was wrong, and you want to retake it, you are able to do that now. You have until Wednesday at midnight. The second thing about this quiz, so from now until the end of the year, for this quiz until the end of the year, if you are taking a quiz online for this class, you need to take it on an actual computer. Do not take a quiz in this class online on your phone. Because if I have pictures, and sometimes I will have pictures, you will not be able to see it on your phone. I don't know why. It's not that the test is broken. Guys, stop talking, please. It's not that the test is broken. It's that the mobile site, for whatever reason, is not optimized to look at pictures for the test or quiz. I don't know why. So from now on, if you are taking a quiz or a test in this class, you need to do it online. You need to do it on an actual computer. Do not do it on your phone. Okay? So you have the quiz open right now. If you need to go in there and take it or retake it, it's open until Wednesday at midnight. Do not wait until the last second. Do not forget about it, because after Wednesday, there will be no more attempts. I am closing it and I am leaving it closed after Wednesday. Yes, Tanner?
So what if I'm good with my grade and I got
Then you can leave it. You don't have to. As long as you have a grade and if you're happy with that grade. But if you want to retry it, or if you haven't taken it, then please go and do that. All right? Okay. So like I said, we started Unit 6. So we started talking about ionic bonds. So the quiz, if you have not taken the quiz is on the very first PowerPoint. So the Unit 6 Day 1 is only on that stuff. So if you have not taken the quiz yet, I suggest, and I highly recommend, that you go back to that very first PowerPoint and you review that PowerPoint, because you've been gone for a week. So review before you take your quiz, okay? So what I want to do, before we start talking about today's notes, I do want to go back and do a review of the ionic stuff that we talked about. So these were notes, I think these were Unit 6 Day 2 notes. So I'm going to quickly go through these notes, and then we will start the next PowerPoint, the next set of notes. All right? So ionic bonds. Ionic bonds we talked about are between a metal and a non-metal. So what is happening is that your metal is going to lose electrons, and your non-metal is going to gain electrons. They are going to make cations and anions. And then the attractive forces between the opposite charges are going to keep those atoms together. So that is what's happening during a ionic bond. And then we looked at some examples. And then we talked about, well, how do we write formulas? So how do we write ionic formulas? Well, I gave you the 3 steps to writing ionic formulas. So your first step is to find the oxidation numbers. If you do not remember how to find oxidation numbers, that is in the very first PowerPoint, and that is going to be on your quiz. So if you do not know how to find oxidation numbers and you have not taken the quiz, you need to go back and look at that PowerPoint you need to know, how do you find oxidation numbers? So for writing the formula of an ionic compound, your first step is to find the oxidation numbers and write them as exponents. Your second step is then to grab your oxidation numbers, crisscross and bring them down, and turn them into subscripts. And then once you have them written as subscripts, your third step is to simplify and reduce if possible. Okay? So that is how you write ionic compounds. Remember, for ionic compounds, your ionic compound has to have an overall neutral charge. So you have to do whatever necessary in order to, at the end of the day, add up your oxidation numbers to equal 0. But if you do these 3 steps, it will do it for you. So just do these 3 steps. Find your oxidation numbers, crisscross, bring them down, simplify and reduce. That is what you did for assignment number 3, the packet. You did that over and over and over and over and over again. And then we talked about transition metals, and then we talked about polyatomic ions. Remember, your polyatomic ions are, the list is on Canvas for that packet assignment. So if you open up the assignment for the packet, you'll see the list of polyatomic ions. You need to memorize those for the test. Okay? So that was writing ionic formulas. We did some examples. We got those right. And then we talked about naming ionic compounds. So naming ionic compounds is easy because the first thing you do is you name the metal and you keep it whatever the name is. So if your net metal is sodium, if it's Na, then the first thing you write is sodium. If it's zinc, the first thing you write is zinc. If it's aluminum, the first thing you write is aluminum. And then the second thing you name is the nonmetal. So you name the metal first, and then you name the nonmetal. The tricky part to this is going to be the third step, which is you have to have the ending as IDE. So you have to take off the ending of your element name and add IDE. The tricky part being, sometimes it's not always clear as to what you take off. So for chlorine, I take off the INE, or I take off the NE, and I add IDE to the end. So it's chloride. That's easy. The one that's difficult is oxygen, because if you notice, oxygen, pretty much all of it's gone. So we had to take off the YGEN and turn it into oxide. That you just have to remember that if you have oxygen in your formula, it's going to have the ending as oxide. Okay? So your metal is named first, your nonmetal is named second, your ending has to be IDE. So that is how you name ionic compounds. And then we did some examples. So Na3N is sodium nitride, KBr is potassium bromide, Al2O3 is aluminum oxide, and MgS is magnesium sulfide. And then we talked about transition metals. So this first step in writing formulas, the first step was to find the oxidation numbers. The oxidation numbers come from our column numbers. Again, if you don't know what I'm talking about, go look at that very first PowerPoint, okay? So our oxidation numbers come from our column numbers. But do our transition metals, all those metals that are in the middle of your periodic table, do those follow the rule of the oxidation numbers coming from your column numbers? No, they do not. So what you have to do is you have to use Roman numeral numbers to tell you, or to be told, what the oxidation number is. So if you have copper 1, you're going to have an oxidation number of +1. If you have copper 2, your oxidation number is +2. If it's iron 2, then it's iron 2+. If it's iron 3, then it's iron 3+. Your Roman numeral number will tell you what your oxidation number will be. So we did a few more examples, and then we did examples with transition metals. So what I'm going to do for your test, what you're going to have to do is you're going to have to turn this formula into the name of this ionic compound. What you have to do for this, because you have to figure out what is the oxidation number for this iron in this compound and turn that into a Roman numeral number. Because you have to tell me which iron are you talking about. Are you talking about iron 2 or iron 3? Well, how you figure that out is you follow these rules. So these rules that I have here and these rules that I have here, but you flip them. You do the opposite. Okay? So instead of grabbing your oxidation numbers crisscross and bringing them down, you take these numbers on the bottom, you crisscross and bring them up. If you do not see a number, you automatically assume that that number is what? 1. If you do not see a number, you assume that is the number 1. Okay? So if you have FeCl3, the 3 and then this imaginary 1 crisscross and go up, and then that tells you your oxidation number. So this 3 crisscrossed and went up to the iron. This 1 crisscrossed and went up to the chlorine. So this tells you that iron has an oxidation number of 3 and chlorine has an oxidation number of 1. Iron is our metal. Metals will always have a positive oxidation number. So iron in this compound has an oxidation number of +3. Chlorine is a nonmetal. Chlorine, all your nonmetals will always be negative oxidation numbers. So this tells you that you have iron 3 chloride. So that's how you name ionic compounds with transition elements. You have to use Roman numeral numbers. Or if I give you this, so if I give you this name, this 3, this Roman numeral number 3 tells you that it has a +3 oxidation number, and then you follow these steps. Okay? So those are your transition elements, and then we also had our polyatomic ions. So that whole packet, number 3, you need to know how to do that for your test. And then I think we might have another quiz before the test, but I'll let you know. But definitely for the test, you will need to know those polyatomic ions. So make sure you're starting to memorize those. Now that you're back from break, go ahead and look at those polyatomic ions and start memorizing them. Okay? So then we did examples. So we have FeBr2. This 2 is going to crisscross and go up to the Fe. So that tells us that we have iron 2 bromide. This 2 is going to crisscross and go up to the oxygen. There is a imaginary number 1 here. So that imaginary number 1 is going to crisscross and go up to the copper. So that's telling us that we have copper 1 oxide. This imaginary 1 is going to crisscross and go up to the chlorine. This 4 is going to crisscross and go up to the 10. So that's telling us that we have 10,4 chloride. This 2 is going to crisscross and go to the oxygen. This 3 is going to crisscross and go to the iron. So we have iron 3 oxide. Not iron 2, because the 2 goes to the oxygen, the 3 goes to the iron. You have to crisscross them when you bring them up. Okay? And then we have CuS. But if you notice, we have copper 2 sulfide. So what is going on here? Well, if you look at just CuS, what 2 numbers do you assume are going to be here? 1. So you have Cu1S1. When you crisscross and bring those up, that tells you that Cu is going to have a +1 charge because Cu is your metal, and metals always have a positive charge. And that also tells you that S has a -1 charge. But if you look at the periodic table, sulfur, S, is in column 16. If it's in column 16 or column 6A, how many valence electrons does it have? Has 6. If it's in column 16, remember you just get, it's okay, we were gone for, I'm right there with you, All right, so if we are in column 16, we get rid of the 1 in front, and that tells us how many valence electrons we have. So we have 6 valence electrons. So we want 8. So what is sulfur going to do in order to go from 6 to 8? It's going to add 2 electrons. But when you add 2 and you gain 2 electrons, are you getting more positive or more negative?
More negative.
More negative. So sulfur is going to have not a -1 charge, but a -2 charge. So if sulfur has to have a -2 charge, and at the end of the day your compound has to be neutral, what does copper have to have for its oxidation number? A +2 charge. So that is why you have copper 2 sulfide. So that you need to be careful of. It's not copper 1 sulfide, it's copper 2. Because sulfur has an oxidation number of -2, which means that copper has to be the opposite of that. These have to add up at the end of the day to equal 0. If they do not, then you have to make it equal 0. Yes, Louis?
So how come, like for the first one, how come bromine isn't 1? Because it has 7 valence electrons.
Right, it has 7. So bromine has 7, it wants 8. So what is it going to do to get 8?
What did you say?
Bromine has 7, it wants,
Yeah, it's gonna add 1.
it's going to add 1. So that's why it has a -1 oxidation number.
Oh, so it does have a 1 and you just crisscross it.
Yes,
Okay.
yes, yes. All right. So that is what we did before you left for Thanksgiving. We talked about ionic compounds and we did all that stuff. And we did more. Okay. So now what we need to do is we need to talk about covalent bonds. All right. So this PowerPoint, this set of notes is going to be number 5 in your notebook. So Unit 7, Day 1. So again, Unit 6 and Unit 7, I am combining them. Unit 6 was on ionic bonds, so we're done talking about ionic bonds. Unit 7 is all about covalent bonds. So now we're doing Unit 7, Day 1. So this is number 5 in your notebook, Unit 7, Day 1, and it is all about covalent bonds. So a couple of questions here about ionic bonds. So why do ionic bonds have very high melting and boiling points?
Do you have to write the questions down?
No. Yes.
Because they're metals.
Because, well, they have metals in them.
Oh, they're polar.
They're polar. What were you going to say, Bailey?
You go ahead.
What were you going to say?
I was just saying Tanner said that they're both burnt.
They have metals in them.
They're strong.
They're strong. Very good, Louis. So your ionic bonds, guys. So your ionic bonds are between a metal and a non-metal. So you have your cation and your anion attracted to each other. Those are very strong bonds. And because they are very strong, they need a lot of energy in order to break those bonds. So that is why they have very high melting and boiling points. Number 2 was an electrolyte. So I don't think I told you what an electrolyte is. So what an electrolyte is, it is in Gatorade, but more specifically what an electrolyte is, so let's say you have a salt. Let's say you have NaCl, okay? When you put that salt in water, what's going to happen is called dissociation. That water molecule, those water molecules are going to break up your salt. And it's going to make your cations, so your sodium ions, and your anions, your chlorine ions, they're going to make them separate. And so what an electrolyte is you have positive ions and negative ions floating around freely, not attached to anything, in water. Okay? Why this is beneficial for us and why we need electrons is in your body, mostly in your brain, you have what are called ion channels. And this is what helps move electrons and move electricity in your brain. This is how your brain works, through ion chains, or ion channels. Ion channels. Ion channels are powered by the movement of electricity and the movement of electrons. So if you have electrolytes in your brain, those electrolytes are going to allow the electricity to move through that liquid or that water, okay? So if you have your ions separated, then your electricity can freely move through that solution. So this is why you need electrolytes, and this is why when you sweat, you lose electrolytes and you need to replenish them, okay? Because if you don't, then your brain stops working, okay? Or you faint, yes.
A lot.
Yes. So that's what electrolytes are. They help power your ion channels in your brain. So that's why they're good. Okay. Number 3, write the ionic formula for a compound containing boron and nitrogen. So again, a review. Your first step. So I give you that you have boron, and I give you that you have nitrogen. So your first step is to figure out your oxidation numbers. So boron has an oxidation number of
-5.
No,
Plus
minus
2.
3. Plus 3. Plus 3.
plus 3.
Oh.
So boron, listen, guys. So boron is in column 13. So get rid of the 1. How many valence electrons does it have? 3. It wants 8. So it could either lose those 3 or it could gain 5. Which one is easier for it to do? It's easier for it to lose 3. When you lose electrons, you get more positive. So boron has an oxidation number of plus 3. Nitrogen is in column 15. So how many valence electrons does it have? 5. So it can either lose those 5 or it could gain 3 to get 8. Which one is easier for it to do? Gain 3. When you gain electrons, you get more negative. So boron has an oxidation number of plus 3. We write that as an exponent. Nitrogen has an oxidation number of minus 3. We write that as an exponent. Our second step is to crisscross and bring down our oxidation numbers. So when we crisscross and bring down our oxidation numbers, we have B minus 3, N plus 3. Your final step is to simplify and reduce if necessary. So simplify. What do I mean by simplify? I mean you do not write the charges and you do not write the number 1. So we get rid of the minus sign, we get rid of the plus sign. And then what do I mean by reduce? Well, for this example, if you have the same number twice, you can reduce both of those to 1. Or if you have a common denominator, so if you have 2 and a 4, you can reduce it to 1 and 2. I don't think you'll have 4 and 8, or 3 and 9, you could reduce to 1 and 3. Something like that. Like reduce them to where they are the smallest whole number forms of those two numbers. So when you simplify and reduce, this you will write as just Bn. So the compound formula for a ionic compound between boron and nitrogen is just Bn. Okay? All right. So that's ionic compounds. So now let's talk about covalent compounds. So we just reviewed ionic. So real quick, let's say you have potassium and fluorine. Potassium has 1 valence electron, fluorine has 7. So what's going to happen is that the 1 electron from potassium is going to travel, is going to travel over to the fluorine. Fluorine is going to gain 1, potassium is going to lose 1, and you're going to form your ions. And then those ions are going to be attracted to each other and form strong bonds known as ionic bonds. Okay, so what about covalent bonds? So remember, whether it's an ionic bond or a covalent bond, your overall goal and the rule that you have to always follow is called the octet rule. You have to have 8 valence electrons in your outermost shell when you are forming these bonds. So ionic bonds, what they're going to do is they're going to give or take electrons. They're going to lose or gain electrons in order to have 8 valence electrons. Your covalent bonds are not going to be giving up and losing electrons, or giving up and taking electrons. You're not going to be gaining or losing electrons. What covalent bonds do is they're going to share those electrons. Okay? But at the end of the day, you need to obey your octet rule. You need to have 8 valence electrons in your outermost shell between all of your elements inside your compound. So rather than losing or gaining electrons, atoms are going to share electron pairs inside of a covalent bond. So for covalent bonds, we are sharing electrons. Ionic bonds are going to be the loss or gain of electrons. Okay. So with our covalent bonds, we have what's called a bonding pair. Those bonding pair of electrons are going to be the electrons that are shared and that are participating in that bond. So that is your bonding pair. The electrons that are participating in that bond, that are being shared, that is your bonding pair. And then remember that your covalent bonds are between two or more nonmetals. So your ionic bonds are between a metal and a nonmetal. Your covalent bonds are between two or more nonmetals. We do have bonds that are between just metals. They are called metallic bonds. And again, they are just between two metals. But they, for some reason, do not focus on that type of bond in this course. So we won't focus on it, but just know that there is a bond between two metals. But we will not really go into depth on that one. So you need to know that ionic is between a metal and a nonmetal. Covalent is between two or more nonmetals. Alright, so let's look at what chlorine does. So chlorine is known as a diatomic molecule. Did I tell you guys what diatomic means?
Probably not.
Alright, well let's review it. So diatomic. The prefix di, di. Does anyone know what the prefix di means? What does it mean? It means two. And then the word atomic just, of course, means atom. So what diatomic means, and you are going to have to eventually memorize I think there's 7 diatomic molecules, but there's an acronym, so when we get to it, it hopefully will be easy. But anyway, so a diatomic molecule is 2 atoms of the same element bonded together. Okay? So what's going to happen, chlorine is one of your diatomic molecules. A chlorine atom is going to go find another chlorine atom, and they're going to form a covalent bond between each other. So chlorine is a nonmetal. If you have 2 chlorines bonded together, you have a covalent bond. You have a diatomic covalent bond.
Wait, that doesn't make sense. Like, so you said that if the two, wait, can you explain it again?
Okay, so we have chlorine. Chlorine is a nonmetal. Chlorine is going to go find another chlorine atom, and they're going to make a covalent bond between those. So if you have 2 atoms of the same element bonded together, you have what's called a diatomic molecule.
Oh, so it's only if they're the same.
Only if they're the same. They have to be the same, 2 atoms of the same element makes a diatomic molecule. All right, so what that looks like is we have these 2 chlorine atoms. Chlorine is in column 17, so it has 7 valence electrons. So you have this electron that's by itself on this chlorine, and you have this electron that's by itself in this chlorine. So what they're going to do is they're going to realize, hey, you want one and you want one. Well, what if we just come together and share these electrons, and then we'll both be happy. So that's what they're going to do. So each chlorine wants to gain 1 electron in order to achieve an octet. But remember, for covalent bonds, we are not gaining or losing electrons. We are sharing electrons. So chlorine, those 2 chlorines are not going to give up their electrons. They're going to come together and share them. So they're not going to give them up. They're going to share them. So what does that look like? They're going to come together and they're going to share those 2 electrons. So this chlorine now has 8. So both of these electrons, remember this one came from this chlorine, but now that they are bonded together, both of these electrons are attached to this chlorine. So this chlorine has 2, 4, 6, 8. So it is obeying the octet rule, so it's happy. And then this chlorine is the same. Now that they are bonded together, now that there are 2 electrons in the middle, this chlorine is going to have 2, 4, 6, 8. So these 2 electrons are being shared between these 2 atoms so that both of these atoms have 8 valence electrons in their outermost shell. So that both of them can achieve the octet rule at the same time. So the octet rule is achieved by both atoms sharing these 2 electrons in the middle. That is a covalent bond. Okay. So this one has 8, this one has 8. So the only 2 electrons that are being shared between those 2 atoms are these 2 in the middle. So these 2 electrons are known as your bonding pair. Okay. So these next couple of slides are going to go kind of one after the other, so I'll repeat them a few times. So this is your bonding pair. These 2 electrons in the middle are your bonding pair. Because you have a single bonding pair, so 2 electrons make up a pair. Because you have a single bonding pair, that is called a single bond, which is also called a sigma bond, but we won't get into depth on that. Just know that it's called a sigma bond. So, backing up. You have these 2 in the middle. These 2 are called your bonding pair. So this is your bonding pair of electrons. Whatever electrons are participating in the bond. So these electrons, all of these electrons are not participating in the bond. So these are not bonding electrons. Only the ones that are participating in the bond are considered your bonding electrons. So the 2 in the middle are your bonding electrons. Because you only have 2, that means you have a pair. So because you only have 2, you only have a single bonding pair. And because you have a single bonding pair, that means you have a single bond. A single bond, so 2 electrons shared together, is represented by a dash. So just one line. So anytime you see one line in between 2 elements, you need to realize that there is an electron here and there is an electron here. So each single line represents 2 electrons being shared together, which is a bonding pair. So one line equals a bonding pair. One line equals 2 electrons shared together. And that is what your chlorine atom looks like. That is how it will bond. Okay, we'll finish this tomorrow.